All right, we're on page 36 today, and we're going to be talking about angle measure. And before we get into measuring angles, we're going to talk about some definitions here. And if you look at your first definition, we've talked about a ray earlier this year, but we have not talked about opposite rays. So the term opposite rays they share an endpoint and form a line. And here's what we mean by that. In this picture right here, if we've got line L and we put points H, J, and K on that line, you've got a ray right here that starts at J, goes through K. This would be called ray JK. Then you've got another ray in this diagram that's called, or could be called, ray JH. The end point of a ray is where the ray begins. So since both of these rays share J as an endpoint, and since line L is a straight line, then ray JH and ray JK are opposite rays. So ray JH and ray JK are opposite rays. Make sure when you're describing opposite rays that they share an endpoint. If you're listing opposite rays, both descriptions should start with the same letter. Both descriptions need to start with the same letter when you are describing opposite rays. All right, and then down below opposite rays, we have the term angle. An angle is formed by two non-collinear rays. The rays are called sides. And the common endpoint is called the vertex. So if we take a point X, and we draw a ray, put point Y on here, and then from X, we draw a second ray. From X, we draw a second ray. put point Z on it. Well, we have vertex X, which is right here. That's called the vertex of the angle. This angle is formed by ray XY. Well, ray XY, when it forms an angle, is called a side. So this is side XY. And the angle has a second side, and we call it side XZ, which is right here. So we've got an angle that has a vertex. It has two sides. You label the side of the angle using the description of the ray that forms the angle. Then we've got this portion of the angle. Everything in here in an angle is referred to as the interior. Anything in that yellow region is the interior of the angle. And then anything in this blue region we call anything in the blue region, that's in the exterior of the angle. So any point that's located in the yellow region is in the interior of the angle. Any point that's located in the exterior or in the blue is in the exterior of the angle. Point X is the vertex. Point Y is neither in the interior or exterior. It's on the side of the angle. Point Z is on the side of the angle. All right, so those are some different terms that you need to know about angles. How they're formed. They're formed by two rays. The rays that form the angle make up the sides of the angle. The common end point for those two rays is the vertex of the angle. And then the angle always has an interior and an exterior. So with that, let's look at the top of page 38. On the top of page 38, we have three types of angles. We have a right angle, and a right angle always measures 90 degrees. The drawing would look something like this. And this little red half of a square that you see, or if you see it in the corner or in the vertex of an angle, that symbol means 90 degrees. So any angle measure that has that half of a red box at the vertex means that it's a right angle and that that angle measures 90 degrees. An acute angle. An acute angle measures less than 90 degrees. So anything that measured less than 90 degrees, an example would look something like this. If we called this angle B, our terminology would be the measure of angle B is less than 90 degrees. The lowercase cursive m we read as the measure. The angle symbol and the less than symbol, they look similar when I draw them, but they are not, well, they look kind of similar in the book, but when you see that symbol between a cursive M and a capital letter B, it means measure of angle B, less than 90 degrees. All right, and in comparison, if we put this dashed ray up here, the red ray going vertical and the black ray going horizontal form a 90-degree angle, but the blue angle in there, or I'm sorry, this angle B right in here, that would be an acute angle. It measures less than 90 degrees. And the third type of an angle we're going to talk about is an obtuse angle. An obtuse angle measures, we're going to say this, that 180 degrees is greater than the measure of angle C, and the measure of angle C is also greater than 90 degrees. And what that is saying is that the measure of an obtuse angle if we call this angle C right here, the measure of an obtuse angle is greater than 90. Set it down, have a seat. Greater than 90 degrees, but less than 180 degrees. All right, if we add this dashed ray in right here, a straight line has an angle measure of 180 degrees. So if we're talking about angle ACB right here, we're talking about this portion of the angle, the yellow region, the highlighted angle there. Angle ACB is an obtuse angle. It measures greater than 90 degrees because 90 degrees would be right here. And it's less than 180 because 180 would be this straight line that runs horizontally along the bottom of the diagram. So an obtuse angle measures less than 90. I'm sorry, greater than 90, but less than 180. Any questions up till now? All right, top of page 39. Congruent angles. Congruent angles have the same measure. Congruent angles have the same measure. If we have an angle here, angle B, and then another angle, angle C. Now, like tick marks, angles have what are called arc marks. And if we put an arc mark in here, they're usually going to be in red. In the textbook, they'll be in red. On your quizzes, they may be in black because your quizzes are all black and white. If angle B has an arc mark and angle C has an arc mark, all right, this is called an arc mark. They work just like tick marks. If angle B and angle C both have an arc mark, a single arc mark, then angle B, here's the symbol for congruent. It's the equal sign with a little squiggly line over the top. Angle B is congruent to angle C. And we read this symbol as is congruent to. Angle B is congruent to angle C. Any questions up till now? All right, and we've got one more term to cover. It's down there on the bottom of page 39, angle bisector. We're going to say that a ray that divides an angle into two congruent angles is called an angle bisector. A ray that divides an angle into two congruent angles is an angle bisector. So if we draw one big angle, and let's label this angle ABC. When you're describing an angle, the vertex is always the middle letter of the angle. This big angle right here is called angle ABC. You could always also describe this big angle here as angle CBA. If you'll notice in both descriptions, the vertex of the angle is in the middle of the description. That's required when you're naming an angle or describing an angle. Now we've got this big angle ABC right here. So to the best of your abilities, we're going to try to draw a ray starting at point B, going out here to the right, that splits ABC into two congruent angles. So something about there. If we put point D on that ray, then we're going to say ray BD is an angle bisector. Oh boy. All right. Ray BD is an angle bisector. Now, if BD bisects angle ABC, then we get arc marks. So if BD is an angle bisector, angle, I'm going to do that in black, angle ABD is congruent to angle DBC. So if we put an angle measure here for angle ABD and we call it 40 degrees, what would be the measure of angle DBC? 40 degrees, very good. And now, what would the measure of angle ABC be equal to? Exactly. He said 80 degrees because this big angle, this yellow angle that we drew initially, would be the sum of the two smaller angles that make it up. So the measure of angle ABC would be 80 degrees. All right, so a lot of new terminology. You can read it again in the book. Those are all highlighted terms on pages 36, 37, and 38, and 39. All right, and then got a couple practice problems for you to do today. So let's look at page. Your practice for today is going to be on page 41. Problems 1 through 10. Page 41, problems 1 through 10. I can't emphasize enough, guys, how important it is to check the odds in the back of the book. And if you're struggling with the odds or you have any questions on the odds, then you need to come see me so I can help you.